Hello guys, welcome to my channel MathTech. I am an working Monday, and today we'll be solving a simple question in mathematics under mathematical induction and matrices. That's a combined question. But before I continue, I would like you to look below the video. You will see the subscribe button. Hit the subscribe button and subscribe to my channel. If you haven't subscribed, then like and comment on the video. If at the process of the video you have any challenge, you can comment your question. You can also give our video a good rating. Thank you so much. So I continue. So this is a simple question. So given the matrix A, and A contains 3 minus 4, 1 minus 1. So we are asked to prove by induction that for a positive integer n, a raised to the power n is equal to, the matrix a raised to the power n is equal to 1 plus 2n minus 4n, n, and 1 minus 2n. So this is actually a simple question, and one of the easiest approach of solving this question is, first of all, understanding the principle of mathematical induction. And this is the principle of mathematical induction. The first step of mathematical induction is you must prove that P of 1 is true. The second step, you must assume that P of k is true for some n equal to k. And the third step, we must assume we prove that P of k is also true. Now I'll give you a very short note. Let me give you a very short note to explain the steps. Now when we talk about prove that P of 1 is true, it means that the correct expression for this is what? P of n. So P of n is also equal to what? P of 1. So wherever you find n, substitute for 1. Same thing here, P of k, assuming that P of k is true for some n equal to k. So wherever you find n, substitute for k. And also for the step 3, wherever you find n, substitute for what? K plus 1. So that's simple. Let's kick off the solution fast. So solution we go. So for the step 1, to prove P of 1 is true. So now going back to the question, given the matrix A, 3 minus 4, 1, and minus 1, we are to prove by induction that for a positive integer n, the matrix A raised to the power n is equal to 1 plus 2n minus 4n, n, and 1 minus 2n. Now, the essence of the proof is to compare if the left-hand side is equal to what? The right-hand side. That is the essence of the proof, to compare if the left-hand side is equal to the right-hand side. Don't forget that we have already given our A, and our A is stated to be what? Our A is stated to be 3 minus 4, 1, and minus 1. So, for the left-hand side, here we are asked to check for A raised to the power n, and A raised to the power n is equal to what? A raised to the power 1, because for the step 1, we have to prove that P of 1 is true. And don't forget, I said earlier that P of n is equal to what? P of 1. So A raised to the power 1, A raised to the power n is same thing as A raised to the power 1, which is same as A. 3, the matrix 3 minus 4, 1, and minus 1. And also we check for right-hand side. Check for our right-hand side. See that the left-hand side is equal to the right-hand side. So we say for the right-hand side, we use 1 plus 2. Wherever we find n, we substitute 1. And minus 4 to 1. Yeah, 1. Yeah, 1 minus 2 into 1. So this is just a simple step, just a step of substitution. Wherever we see n, we substitute with what? 1. So that's simple. We continue simplifying them, and you see this is already a matrix. So the part, the left-hand side, which is a raised to the power n, still remains 3 minus 4, 1, and minus 1. Now let's equate it to the right-hand side to see if it's the same. So here we see that 2 into 1 will give us 2. So here we still have 1 plus 2. Here minus 4 times 1 gives us what? Minus 4. We still write down the 1 here and here. 2 times 1, minus 2 times 1 gives us minus 1. We still have it to be what? 1 minus 2. So, solving this right hand side, left hand side will remain the same. The right hand side will be 1 plus 2, 3. And here we have minus 4, here we have 1. And 1 minus 2, we have what? Minus 1. So, at the end of this, we can see that our left hand side is equal to the right hand side. So we can see that for the step 1, to prove that P of 1 is true, yes indeed it is true, because when we substitute our n to be 1, the left hand side gives us what? The right hand side. So we conclude that therefore P of 1 is true. So this is simple, but this does not prove if indeed the left hand side is equal to the right hand side. For you to prove this by mathematical induction, you must solve the first step. The first step must be true, and the assumption of the second step must be true. Then the third step must be true. So this is just for step 1. So let's go over to step 2. So now, since we have successfully shown that the step 1 is true, now let's check for the step 2. Now, you must understand that the step 2 is not really complex, it's just an assumption. The principle says that you assume that P of K is true for some n equal to K. So we all know what to do wherever we find n, we substitute for K. So we are comparing the left hand side and the right hand side, and this is the left hand side, A raised to power n, and this is our A. The matrix A is 3, 1, minus 4, and minus 1 raised to power n. So wherever we find n, substitute for K. So we put raised to power K instead of n, and this is equated to wherever you find n in the right side, substitute for K also. So we have the right hand side to be the matrix 1 plus 2K minus 4K, K, and 1 minus 2K. So this is just the solution to the step 2. As simple as this, it's just an assumption. So we assume that the left hand side is equal to the right hand side. But when we are studying in step 3, you will understand why this assumption was made. This assumption is what gives us the leverage to solve this step 3. So let's move on to the step 3. Now we move over to the step 3. Now for the step 3, we have to prove that P of K plus 1 is what? True. Don't forget I told you that from the beginning I said P of n is equal to P of 1. So likely P of n is also equal to P of K, and so likely P of n is also equal to what? P of K plus 1. So wherever you find n in this matrix expression here, we substitute for what? K plus 1. So now we are given the matrix here, A raised to power n, knowing that our A is equal to this matrix up here. So here we are to have A raised to power K plus 1, and this is equal to our right hand side, the matrix at the right hand side is 1 plus wherever we find n. So since this is not just one value, this is K plus 1, these two values here are being separated by an operator, this variable and this value are being separated by an operator. So we have to put it in brackets. Now it is very wrong to write it as 1 plus 2K plus 1. This is wrong. For writing it will be 1 plus bracket K plus 1, and we have minus 4 bracket K plus 1, and here we have K plus 1, and here we have 1 minus 2 bracket K plus 1. So this is what we will have here. But at this point, this step 3 is a bit complex, so we have to take it step by step, starting from the left hand side before we go to the right hand side. Now let's break the left hand side. Let's simplify it. Now, how do we simplify this kind of expression? Let's say we are substituting our matrix of A, and we are having this to be matrix 3 minus 4, 1, and minus 1. And our n is k plus 1, k plus 1. So there is definitely no direct way of solving this except we apply the law of indices. And now don't forget that the law of indices says, now I'll use this expression again. The law of indices says, if you have a raised to power n times a raised to power n, actually this is the first law of indices, it is always equal to a raised to power n plus n. So now we can see similarity between this law of indices here and this matrix here. There's a similarity here. So what we definitely do here is applying same law here. So since here we are having the right hand side, so we make the right hand side here to look like the left hand side following the matrix we are given here. So definitely what we will have here will be what? A raised to power k times a raised to power 1, and this will be equal to what? A raised to power k plus 1. So this left hand side here is equal to this right hand side. So we'll pick this approach on the left hand side. This is what we'll work with, the left hand side. We'll use the left hand side of this expression to simplify the left hand side of our proof. So let's do that now. Okay, so now we are simplifying the left hand side, and from the explanation I made earlier, so we'll be using, we'll be breaking this to the law of indices, and we are using this expression. This expression is same as this. So what we this is a raised to power k and this is a raised to power 1. This is also equal to this. So now this takes us back to step 2. Remember in step 2 we made an assumption that a raised to power k, in step 2 we made an assumption that a raised to power k is equal to, a raised to power k is equal to 1 plus 2k minus 4k, k, and 1 minus 2k. So we made this assumption in our step 2. That was the assumption we made in our step 2. So we use this assumption here in place of a raised to power k, and here we'll be having, in place of a raised to power k, we'll be having 1 plus 2k, and here we will have minus 4k, here we have k, and here we have 1 minus what? 2k. And we'll multiply this with a, which is a raised to power 1, as step 1, which is same thing as what? A, which is the matrix here, times 3 minus 4, 1, and minus 1. So at this point, it leads us to the multiplication of matrices. I will not explain in details the multiplication of matrices, but I will just give a simple hint on how you can multiply matrices. If you want to learn more about multiplication of matrices, I will advise you keep watching my video. We'll post a tutorial soon, a complete matrix tutorial, and you will learn every part of matrix you wish to learn. So let's continue with this. So in multiplying these two matrices, this is how it goes. You use the first row to multiply the second column, and it gives you the first value here. Okay, just a simple instance that I'll give here. If you use the first row to multiply the first column, you get the value here, say A. You use the first row to multiply the second column, we get the value here, B. Since this is a 2 by 2 matrix, so it also returns to a 2 by 2 matrix. And now we then use the second row to multiply the first column here, we get C. And we use the first column here to multiply the second column here. We have the first row, the second row here to multiply the second column. We have here D. So this is how the result will be. But I will show you this is not just A, B, C, D. I'm just using it as an instance how the arrangement will be. So I will show us how it goes. So now using this first row to multiply this first column, now you say you pick this first value here in the first row and multiply with the first value here in the first column here. And here we'll have 1 plus 2k times 3. Since these two values are separated by an operator, so we write it as 3. This is the best way to express the multiplication. 3 into 1 plus 2k. So after using this to multiply this, there is always a need for a positive sign to separate this first multiplication and the second multiplication. So we then use this to multiply this. So minus 4k times 1, and here we start minus 4k. Since it's going to be negative, we can put it in bracket first before we simplify it. So we have here to be what? Minus 4k. So we can see that this is our A, just as we pointed. This is our A. Let me write it somewhere. Let me write it somewhere down. We have to get a 2 by 2 matrix also result. So this is our A. This value here, this expression here is our A. So we go to the B. We go to get our B. Now this is the first row to multiply the second column. Just as we did for this first step, getting here, that's how we do. We use the first value here to multiply the first value here, and the second value here to multiply the second value here, separating them with a positive sign. So 1 plus 2k times minus 4, since this two values here are being separated by an operator, so it will be written as minus 4 into 1 plus 2k, minus 4 into 1 plus 2k, and minus 4k times minus 1. Now there is a basic rule of arithmetic I would like us to learn. And what is that rule of arithmetic? The sign rule, which is minus times minus equal to plus, plus times minus equal to minus, minus times plus equal to minus, and plus times plus equal to plus. So this rule is very important. Many people have failed many exams because they failed to observe and understand this rule. So we are applying this rule here. Now we are having minus 4k multiply minus 1. So at this point we are having a minus multiply a minus, and that results to what? A positive value, and here we'll be having plus 4k. So we've seen that we've successfully gotten our A after multiplying year by year and year by year. I also successfully gotten our B following the same procedures. So we go to get our C, and we also go to get our D. So for getting the C and the D, we use the second row to multiply the first column and the second row to multiply the second column. So now k times 3 will give us what? 3k. So don't forget to also use this to multiply here. Minus 1 minus 2k times 1. Anything that multiplies 1 still remains the same. So we do plus bracket 1 minus 2k. But this is actually optional. Putting the bracket is optional. Why? Because the operator here is positive. Now, assuming the operator here is negative, the bracket would have been very compulsory, because the negative sign will influence this bracket here. But at this moment, since it's positive, nothing changes, everything remains the same. But it still remains optional to put the brackets. So we go to get our D, we got our C, now let's get our D. For our D, we use here to multiply here. 4 times minus k, you can see that, k times minus 4, we can see that here minus 4, this is negative, and here k is positive. So positive times negative gives us what? Negative. So here we have what? Minus 4k. Don't forget, it must always be the two values you will get here. The two values you will get must always be separated with what? A positive sign, plus 1 minus 2k times minus 1. So this expression here, 1 minus 2k, is a positive expression, but also there is a negative operator that separates the two values here, and you are now multiplying it with a negative value also. So, but the major thing we have to note is that our minus, this is a simple way of writing this expression. We can write this expression as minus 1 times brackets, minus 1 times brackets, 1 minus 2k. I'm trying to solve it step by step, break everything down for us to understand this step by step. So please follow up. So this is the best way of writing it, and this can also be minus bracket 1 minus 2k. But I don't want us to do away with our plus sign for now, so I would like us to continue with that. So I will just do a double bracket here, this minus bracket 1 minus 2k bracket. So this is simple. So with time, we will understand each of these with time. I will break everything down to the smallest part of it so that we can all understand the calculation. So this is it, and this is where we are. After this is the value, this is the result of the multiplication. So let's simplify the results we are getting. Simplifying the results, we can see that 3 multiply this bracket, so we use 3 to multiply the values inside the bracket, and here you'll be having 3 times 1 we have 3, and 3 times 2k we have plus 6k, and this is now plus separating this value here from this other value. So but this other value here is negative, so plus times minus, which is plus and minus, is going to give us what? Minus. So we have here to be what? Minus 4k. So the plus times minus 4 gives us what? Minus 4k. So simplify the first value in the first row. Let's go here and we'll also do the same simplification here. Use minus 4 to multiply through the brackets. We have minus 4 times 1. We have what? Minus 4. And minus 4 times 2k. Minus times plus. Minus times plus gives us minus. And 4 times 2 gives us 8. 4 times 2k gives us 8k. So we have here to be what? Minus 4 minus 8k. And this is plus 4. Plus 4k. That's what we have here. And coming here, we have this part to be what? 3k. 3k plus 1 minus 2, we just open the bracket, nothing changes at that particular point. And at this point, we simplify here also. But before we simplify here, let's deal with this bracket. So at this bracket, this is what I want us to note. I want us to note that this minus multiplies all through this bracket first. So here we are having this simple expression minus brackets. Okay, we have it here, minus bracket 1 minus 2k. So using this negative sign to open the brackets, we'll have it what? Minus 1 plus 2k. So minus 1 plus 2k, minus 1 plus 2k. So what we then have here will then be minus 4k minus 1 plus 2k. So this is how we will simplify it. Then we pick like terms. So we go here, we have 3. So 6 minus 4 will give us what? 6k minus 4k will give us what? 2k plus 2k. And here we see we are having same here. The variable here k is having coefficient minus 8. And the variable here k is having coefficient what? Plus 4. So minus 8k plus 4k, following the number line, we will have the result to be what? Minus 4k. So here will be what? Minus 4 minus 4k. There will be minus 4 minus 4k. And coming down here, we have 3k, and here we have 2k. So 3k minus 2k to be what? That will be k. So here we have 1 minus k. Here we have no k, that's 1 plus k. Because 3k minus 2k, it will give us k, that's positive. So here will be 1 plus k. And coming here, we are having minus 4k and we are having 2k. So minus 4k plus 2k, that will give us, following your number line, that will give us what? Minus 2k. So here we'll be having minus 1 minus 2k. So this is the result of the left hand side, and this result is for what? Is for what? Our a raised to the power k plus 1. This is the result for our a raised to the power k plus 1. So we have successfully checked out for the left hand side. So our a raised to the power k plus 1 is now 3 plus 2k. And here we have minus 4 minus 4k. And here we have 1 plus k, and here we have minus 1 minus 2k. So now let's check for the right hand side. Though you know we are supposed to check for if this left hand side, which results to this, is equal to the right hand side. Now, having this matrix in the right hand side, this is the right hand side, so let's simplify the right hand side. So here we are having 1 plus, so now 2 into these brackets, so we have this 2 multiplies 3 brackets, so we have 1 plus what? 2k, which is 2 times k, and 2 times 1 plus 2. So here we come here also, and here we have minus 4 times k, we have minus 4k, minus 4 times 1, minus times plus, don't forget the roots, minus times plus gives us minus, so that will be, here we minus 4k, and here we have it minus 4, coming down here it remains the same, k plus 1, and here 1 minus 2 into k plus 1, so minus 2 multiplies this bracket, so 1 minus 2 times k gives us what? Minus 2k, and minus 2 times 1 gives us what? Minus 2. Minus 2. So simplifying the right hand side. So now let's add. If there is need for like terms to get like terms, we get like terms. But you can see that we have our like terms here are more of the constants. So we have here to be what? 1, and here we have here to be 2. So these two can work with the operation. So 1 plus 2 will give us what? 3 plus 2k, which is on its own. Since it is affected by a variable, so it cannot be added or subtracted because of it is not alike with these other values which are constants. So this is minus 4k and minus 4. No operation can be carried here. Same thing here, k plus 1, and here we also have what? 1 minus 2k. No? You see that we are having like common terms here. We are having 1 and we are having minus 2. These are constants. So 1 minus 2 is what? Minus 1. And now minus 2k remains here, and minus 2k. And we can see that this is the result we get from the right hand side. Now let's compare if the result we got from the right hand side is equal to the result we got from the left hand side. So our result from the right hand side, you see this 3 plus 2k, the first value in the first row, 3 plus 2k, same thing for the left hand side, same thing for the second value here, minus 4 minus 4k, minus 4 minus 4k, it's same thing as this. And also here, 1 plus k, and here we also have k plus 1, same thing as this. So, and this also we are having minus 1 minus 2k, so this is same thing as this. So it means that we have successfully proved by induction that for a positive integer, n, a raised to the power n is equal to this. So at this point, we conclude, since p of k plus 1 is true, and also p of 1 is true, and p of k is true, therefore for all positive integer n, a raised to the power n is equal to 1 plus 2n minus 4n, and 1 minus 2n. So this is the conclusion we'll take since p of k is true, and also p of 1 is true, and p of k. So here is p of k plus 1, and here is p of k is true. Therefore, for all positive integer n, a raised to the power n, the matrix a raised to the power n is equal to this matrix here at the right hand side. So at this point, okay, comparing, we can just add an equal to sign that this is equal to this. This is equal to this. So therefore, we have successfully proved this by induction.